Hello, so I want to talk about number 16. I've had a few questions about these transformations, and hopefully this video will get you headed in the right direction with these things. So in this problem 16, you're given a function, right? The graph above is f of x. So just to be clear, this guy up here is f of x. And the graph below is g of x, and it says that g of x is a transformation of f of x. Specifically, it is a times f of b times x. So we're doing some multiplying when we make g of x, right? We're doing the transformations that involve multiplication. So typically those are vertical or horizontal stretches, and if we change the sign, it would be also a reflection. So let's first talk about this a. That when you multiply on the outside of a function, when you multiply by some scalar, let's say we double it, what that would do is that would multiply all the y values by 2. So they'd stretch them out, right? And as I look at this graph, I notice it starts out where the top is at 1 and the bottom's at -1. And I look at the transformation, it did not get stretched vertically. It still tops out at 1 and the bottom is still -1. So even though we're multiplying by some value of a, we are not changing that vertical size. We're not stretching it out. So essentially what we've done is we multiplied by 1, and so that's what I'm going to put in that first blank. My a is just a value of 1 because we didn't stretch this thing out, and it didn't reflect either. The short piece is still on top, and the longer piece is still on bottom. However, when we look at what happened horizontally, it looks like two things have happened. The graph flipped over the y-axis, right? It started out with the short part to the left and the long part to the right, and now we have the shorter part to the right and the longer part to the left. So there was a reflection there. What that tells me is b is negative, right? B is going to be less than 0 or negative because there was that reflection. The second thing I notice is this thing definitely stretched out, right? It started out between -1 and 2, and it ended up at 1 and -6. So let's think about that. Remember, this 1 flipped over to this side, and then it ended up as a 3. So the way you turn a 1 into a 3 is you multiply by 3. Same thing for the 2. It started out as a 2 here. We flipped it over to -2. It ended up at -6. -2 times 3 is -6. So we've stretched this by a factor of 3. One thing you need to remember, though, is when you're messing around on the inside of the parentheses, when you're composing something into this function, it's the opposite of what you think it is. So when we have the translations, if we put x plus 5 in the parentheses, it actually shifts it to the left 5 instead of the right. If you put x minus 2, it shifts it to the right 2 instead of the left. And it's the same thing with these scalars. And since it looks like it got bigger by a factor of 3, what we need to remember is we're really dividing by 3. So in the parentheses, I've got this negative, and I've got this growing by a factor of 3. So in the parentheses, that would look like this, -x divided by 3. Now, b does not include the x part, so we just want the b part. The b would then be -1/3. So in the box, I'm either going to put -1/3, or if you want to use a -0.3 repeating for a decimal, you could do that as well. But that's how we deal with these scalar transformations. These are stretches and reflections, and we achieve those by multiplying either outside the function or composing it inside the parentheses of the function there next to the x. Hope that was a little wordy, but hopefully it helps get you headed in the right direction on number 16. Your problem may look slightly different, but if you have questions, feel free to keep asking. I'm here to help. In the meantime, take care.